Okay, since we've factored quadratics, now we're going to move to graphing quadratics. So when I graph quadratics, they're all going to have the same shape, right? And that's going to be a U shape. Okay, so if I sketch U here, right, this is actually our parent function, y equals x squared. All right, we could plot points to figure this out. So if I were to plug in -2, right, -2 squared is a positive 4 because it's -2 times -2. So that's this point up here, right? Then if I have -1 squared, that's a positive 1. So I'm at 1, 1. Then if I have 0 squared, that's 0. Right? Then if I do 1, 1 squared is 1. And then 2 squared is 4. Right? So it's symmetrical, right? It's the same on both sides because a negative square is going to be positive and a positive square is going to be positive. Okay, we call this U a parabola. All right, that's the name of the shape of a quadratic. All right, now I said it was symmetrical, so we have what we call our axis of symmetry. And we usually abbreviate it and label it AOS. Just save ourselves some time writing. It's a lot of words. Your axis of symmetry is right smack dab in the middle of your U, of your parabola, right? Because it's the exact same on both sides of that axis of symmetry. So for this example, the y-axis is actually my axis of symmetry. Okay, we always label our axis of symmetry with a dotted line, all right, and it's always in the middle. Another thing that's in the middle is our vertex. Okay, this is the highest or the lowest point, or your max or min value. Okay, your highest or lowest. In this case, it's a minimum, and my lowest point right smack dab in the middle, right? So that's my vertex. Okay, your vertex is always on the axis of symmetry. Okay, then we got this A value here. Okay, so for the A value, all the forms we're going to look at today have an A value, right? It's always in the front, okay, and you'll see it when we start writing out our forms. But that A value tells us something important no matter what form we're in. If I have a positive A value, that means that my parabola opens up. So that means it's a touchdown. It's a U shape. Okay, but if I have a negative out front, if I have a negative A, that tells me it's going to open down and be a mountain. Right? And that's big when it comes to graphing because sometimes you can, know what your graph looks like just by looking at the A value. So if it's a positive, it opens up, a negative opens down. Okay, we got 3 forms of quadratic equations we're going to look at. The first 2, all we're really focusing on is being able to write the equation when you're given the graph. So we're not so much graphing from vertex form and intercept form, but I'm going to give you a graph and you have to be able to write the equation or fill in the equation. Okay, so the first example, or the first one we're going to look at, is that vertex form. All right, the way vertex form looks like without any numbers in it is A times x minus h squared plus k. All these letters we're throwing in there. Okay, x always stays x, right? Whenever we have in our equation, we're always going to have an x and a y in it. But the a, h, and k we plug in. All right, now we call it vertex form because we can get the vertex just by looking at the equation. All right, so my vertex, all right, is at the point h, comma, k. All right, h comma k is where my vertex is, and I can get that straight by looking at the equation, and I can also take it and put it right back in the equation. But there's one important thing. H is always the opposite sign. Okay, and we're going to see h a lot more in math too, right? We're going to talk about transformations and stuff with h, and h is always opposite sign in all of the equations we look at. All right, so for the first 3 up here, all we want to do is write the equation. Okay, so I'm going to write an equation that looks like this, but I plug everything in. Now for all of these, a is going to be 1. Okay, so I don't have to worry about a just yet, except I might have to put a negative out there. Okay, so that's the only thing we have to worry about with a, but it's always going to be either positive or negative 1. Okay, so for the first one, it's a U. It opens up, so that tells me we're going to have a positive A. For the second one, it opens down, so that tells me I'm going to have a negative A. And the third one opens up, so there's my positive A again. All right, so now when I write my equation, I'm going to have x in parentheses. All right, and I need my vertex to be able to write it. So my ordered pair right here, my vertex, is at -3, +1. Okay, well this is my HK point. All right, H is opposite sign. So when I go to plug it in here, it's a -3 here, which means it's going to be a +3 in my equation. All right, my A value is positive, so it's going to be a +1, which I don't have to write there. Okay, and it's always squared because we're working with quadratics. And then my K value is a +1, so I'm going to put a +1. So the equation for this one's going to be x + 3 squared +1. For the second one, my vertex is at 2, 3. So I got y equals, right? I got my parentheses. +2 for H means -2 in parentheses. +3 means a +3 on the outside. Now I left a space here because I have a -1 for my A since it goes down. So I'm just going to put a negative there. You don't have to write the 1. Okay, then for the last one, I got a positive A, so I don't have to worry about it. In my parentheses, my vertex here is at -1, -3. The H value is opposite, so it's really a +1. K value is a -3, so I'm going to put a -3. Okay, biggest mistake, you forget, you either keep them both the same sign or you change both sides, but you can't do that. The H value is in here, opposite sign. The K value is on the outside, same sign. All right, so find your vertex, plug it in. That's it. You're just writing the equation using the vertex off of your graph and the fact that it either opens up or down. All the ones I'm asking you for right now are going to be either a negative out front or nothing out front because it's always going to be a 1 for A. Okay, for intercept form, okay, we call it intercept form because it's going to give you your x-intercepts. Okay, just like vertex form gives us a vertex, intercept gives you the intercepts. Okay, so the way we write it, we have that A that's out front, but then I'm going to go to parentheses. Okay, and this is going to look familiar. So I'm going to have x minus P and x minus Q. All right, now P and Q are my x-intercepts, and just like H, they're always the opposite sign. Always, always, always. Anytime we take something from inside parentheses out, it's always going to be the opposite sign. Okay, and again, for the ones that I am asking you for right now, A is either going to be a positive or a -1, but I'm not going to give you a numerical value other than 1 for A. All right, so for this one, similar to vertex form, where I have to find the vertex and plug it in, here I have to find the x-intercepts and plug them in. Right, so for the first one, I have 2 x-intercepts. Okay, one of them is at 1, 0, and the other one is at 3, 0. So we're going to come down here to y equals. This one is a U, it opens up, so that tells me I have a positive A, so I don't have to put anything out front. And then in my first parentheses, I'm going to put the 1. Now it's a positive 1, so when I put it in my parentheses, it's going to become a -1. All right, the second one is a positive 3. So when I put that in parentheses, it's going to be a -3. And there's my intercept form. X minus 3 times x minus 1, or x minus 1 times x minus 3. Does not matter what order you write your parentheses, as long as your signs are correct for the numbers. Okay, for number 2, my x-intercepts, I got one at -3, and I got one at +1. This one's going down, it's a mountain, it's upside down U, so that tells you I'm going to have a -A, so a negative out front. So I have y equals, got a negative. I'm going to start with the left one, doesn't matter which one we start with. Right, a -3 is going to become a +3 when I plug it in, and a 1 is going to become a -1 when we plug it in. And there's our equation in intercept form. Okay, the last one, I have a positive A, so it's going to open up. and I have an x-intercept at -2. So I don't have to worry about anything for my a. If I plug in a -2, I have x plus 2. And then, oh no, this one looks weird. Totally messed up. I don't have multiple x's in there, right? I'm not going to have x squared. This one's linear, right? But it's a parabola, so I still have to, make my equation a quadratic. If you only have one x-intercept, that means it's going to be x plus 2 squared, right? And you can think about that. This is also technically vertex form, right? Because it looks like the ones we wrote up here, but I don't have a k. So it's kind of like saying this is plus 0. So my vertex would be at -2, 0. Well, here's my vertex at -2, 0. All right, so if you only have one x-intercept, it's going to be x plus 2 squared, or put your intercept in there and squared on the outside. Okay, the last one, we're going to do the opposite. We're going to actually figure out the graph based on the equation. So this one's got some more steps to it. All right, my standard form we already mentioned when we were factoring, and that's ax squared plus bx plus c. That a, b, and c is going to help me figure out what my graph looks like. There's two things that we need in order to be able to graph when it's in standard form. Right? The most important one's actually the vertex, but it takes a second to get there. So I started with the y-intercept. The y-intercept is going to be another point that I can use to graph my equations, and it's super, super easy. Whatever c is my y-intercept every single time. Because your y-intercept is when x equals 0, and if I plug in 0, anything times 0 is 0, so everything goes away. But the biggest thing is that y-intercept is always your c value. Right? Vertex, all right, I'm going to get by figuring out the axis of symmetry. Okay, remember, when we sketch this, your vertex is always on that axis of symmetry. So I can't just get the vertex from standard form, all right, because it's not vertex form. So I have to first figure out my axis of symmetry, then I can figure out what my vertex is. All right, now I have a formula for axis of symmetry, and that's -b over 2a. All right, -b over 2a. All right, so only doing 2 of these because they take a little longer. So for the first one, we got x squared minus 4x plus 1. So I'm going to start with figuring out my axis of symmetry. So my axis of symmetry, right, is going to be -b over 2a. All right, so in this case, my b is -4. So that's going to be -4, right? You're going to change the sign every time. And then 2a. Well, my a is out in front there, so it's a 1. So -b over 2a is -4 over 2 times 1. Well, negative becomes positive. And then 2 times 1 is 2. 4 divided by 2 is 2. So my axis of symmetry is at +2. All right, so I'm going to come down here. Oops. All right, and I'm going to go ahead and put my dotted line at 2. So I'm going to go to 2 here, and it's always x equals. Okay, so the middle of my u, the middle of my parabola, is going to be at x equals 2. All right, that means on this dotted line is my vertex. So that means my vertex is going to be 2 comma something. And I got to figure out that something. So to do that, I'm just going to plug in 2 to my equation. So we're going to say 2 squared minus 4 times 2 plus 1. Well, 2 squared is 4. 4 times 2 is 8. 4 minus 8 is -4. Plus 1, we get -3. So my vertex is down here at 2, -3. All right, then the next thing I use is my y-intercept. I'll switch colors here. Y-intercept is always c, so my y-intercept is going to be at 1. So I'm going to go up here and put a dot at 1, my y-intercept. So I can go ahead and connect these, and there's half my u. Well, I need the other half. I got to know where to, draw it on this side, and lucky for us, a parabola symmetrical, and it's going to be the exact same on both sides of my axis of symmetry. So that means I can come over here and put that same point to get the rest of my U. Okay, now I just did a whole lot of talking through that. Doesn't take quite as long. So for the second one, I'm going to go a little bit faster, and it's going to be the same steps to do this every single time you have to graph in standard form. Right, so the first thing I'm going to do is get my paper straight. All right, so first thing, I need to figure out my axis of symmetry. So that's negative b over 2a. So I got negative, and my b in this case is 6. And then 2 times a, 3. All right, so negative 6, 2 times 3 is 6. So we get negative 1. All right, so I'm going to come down here, go ahead and start sketching my graph. And at negative 1 is my axis of symmetry. Then I'm going to take that negative 1 and plug it into my equation to figure out the rest of my vertex. Then my vertex is at negative 1 something. So I'm going to take my x, plug it in to figure out what y is. So 3 times negative 1 squared plus 6 times negative 1 plus 5. Okay, negative 1 squared is positive 1. Common mistake. If you square negative, it's positive. And then 3 times 1 is 3. 6 times negative 1 is negative 6, then plus 5. 3 minus 6 is negative 3. Negative 3 plus 5 is 2. So my vertex is at negative 1, 2. My y-intercept is always C. That's at 5. So we got 1, 2, 3, 4, 5. So there's half my U. Got to get the other half by reflecting that point over. And there's my U. Okay, it's a lot of steps, it's more work, but you start by finding your axis of symmetry, negative b over 2a. Take that value, plug it in, that's going to give you your vertex, and then use your y-intercept and reflect it over to get all the points you need to be able to draw your U shape.